let us talk about interval notations. So interval notations it is just a way of representing real numbers on the number line. It is a way used to it's more like a format of representing real numbers on the number line. There are quite a lot of real numbers. Remember, even rational numbers and irrational numbers are real numbers. But here we only deal with real numbers that are able to be represented on the number line. So we represent a set of numbers which are real numbers that are able to be represented on the number line. So this is another way of representing a set, but in this format, on this interval notation, we represent those sets. We represent sets that are having real numbers that can be represented on the number line. Just like they are the same way we had set builder notation and interval notation. And for this topic to make sense, you need to know about set builder notation and roster notation, which I talked about in the introductory video, introduction to sets. You can go and check out the video. Okay, so now let us proceed. So as I said that we use interval notation to, it is another form of or a way of representing a set of numbers, right? So let us assume that we have maybe let's say set A. Imagine we have set A. Set A is having these numbers, which are natural numbers: 1, 2, 3, 4, 5. Okay, let me just end on 5. Okay, so now remember these are accounting numbers, right? So this set is in roster notation, right? So we can convert this to, or we can take it to interval notation. Now, how do we take it to interval notation? Interval is more like you're just giving an interval. Interval is more like a range, like a distance between this point and that point, right? So now, instead of listing them all the numbers, now the numbers are from 1 to 5, you can just easily say, right, like this. We can just say A. You use the square bracket. I'll explain that. So where remember that the numbers are going in order. Only the numbers that are able to be arranged in order can be represented in intervals. So now an interval is like you're just describing how the numbers are. So here we're just saying the numbers are starting from 1 ending up to 10, right? So now where are we starting from? We're starting from 1. We're starting from 1, and 1 is also part of the set. That is why we have used this the square bracket. And where are the numbers ending to? They are ending at 5, right? So now you're going to write 5. Use a square bracket, because you are saying that this 5 is also part of what? Part of the set. Even this one is also part of the set. So another example, let's say maybe we have let's say we have B. Now, let's say this time let's say we are starting from maybe 3, 4, maybe ending up to 6. Okay, so now let's say B is equal to, so now remember, when we are representing the set that is an interval, we are just saying the range, like an interval of these numbers. So now another way of representing, it's not always necessary that you can begin with the number where it is starting from. You can begin with the number that comes before the first number. So now, which number comes before 3? It is 2, right? So you write 2. So now when you are writing a number, now this 2 is not part of the set. It is not part of the set. And when you're writing a number that is not part of the set, you simply do this. You use the parenthesis, a single parenthesis, this. Don't use the square bracket, you get it wrong. So you use this, and instead of saying no, we are ending up to 6, we're not, you can further go to 7. You can just say 7, but the moment you just write this, you are saying that we are starting from, the moment you just write this, you're saying the first number is not where we're starting from. We're starting from what comes after this number, which is 3, ending up to what comes before this number. It is what? It is 6. As simple as that. So now the moment you just see that this is used anywhere, hope you understand. Sometimes they can be combined. Let's say maybe if we want, we can also write like this, 2 to 6. But this time, since 6 is part of the set, you can just write the square bracket like this. Okay, you are describing the set. So now oftenly, maybe, I mean not oftenly, sometimes you'll be given in set builder notation, like the question that I'm going to solve. Let me just give an example. Maybe let's say you've been given like this. Let's say you've been given like let's say set C. Remember I showed you another form in which they can represent the numbers. So when you're dealing on interval notation, always remember that we always deal with real numbers. So there is another way where they can say each value of x is a member of real numbers. Now since real numbers are a lot, let's say they have given you a range. Let's say you've been given a range. In this case, let me say like let's say it is starting from 2. Okay, let's say x is greater than 2, just like that. So now it is you. Now you are going to interpret. Remember I talked about intervals. They're simply saying that this is a condition A and this is the type of numbers that we're dealing with. So they're simply saying that x is for every member of set of real numbers are a lot, right? Now they're only interested in those real numbers that are 2 going above. When you look at how the number line is, meaning that we're going to go 2 and upwards, right? So now for you to understand this, you can convert it now to roster notation, which is this one. So here they are simply trying to tell us that these numbers, they are real numbers, and real numbers that are starting from 2. Now look here carefully. There is an equal sign, meaning 2 is included, right? So you're going to start from 2, 3, 4. Now they haven't set the limit where we are ending to. So meaning it is going to the infinity. Just add 3 dots. You are describing to the infinity. Okay, so you can further now represent this into interval notation. Now. Interval notation, remember how you represent. So now you can, since now these two, and when you're representing in interval notation, make sure that you use the number which has been given you. Don't start with 1. No, if you have been given like this, just start from 2. It is you to see whether there is an equal. If there is an equality, it means that it is included. If it was just like this, it means that don't include 2, just start from 3. They just want those that are greater than 2, but here they want those that are greater than and equal to 2. So you should start from 2. So meaning you're trying to say that in this set the first number is 2, square bracket, right? So now it is going to the infinity, and we don't know where the infinity ends from. So we don't know the number, we don't know which number, since there are a lot of number to the infinity, like it's you can't finish counting, it's uncountable. So we don't know where it is ending to. We don't know. So infinity, it is considered not to be part of the set. So you're just going to write the symbol for infinity. Now you need to be careful here. So here we are going to this side, right? And when you look at the number line, when you're going towards this side, you're going to the positive side, right? So now, since you're going to the positive side, here it is infinity. Remember, we haven't been given the limit we're ending to. So now, you need to write the infinity symbol, which is written like this. And you add a plus here. And you put the single parenthesis like this. But let's say maybe instead of them writing like this condition, let's say maybe they wrote like this, x. Let's say maybe there was like okay, let me write like this. Let's say maybe it was like this. Let's say maybe there is 1. let's say maybe there was 1, then x, then maybe let's say 5. Okay, so now as you can see here, they are trying to say that this x is between 1 and 5, but for the fact that there is no equality here, don't you should include, of course, make sure you include this on the interval. You can write like this. Now one thing that you should consider is for the fact that, okay, you're going to write like this. So now you're going to include this number and this number on your intervals when you are writing the notation. So now, but remember that you are not including this because there's no equality sign here. So meaning 1 and 5 are not part of the set. So we are going to use this single parenthesis symbol, and we are going to write 1, separate by a comma. It is starting from 1, which is not going to be part of the set, meaning that you're going to start from 2, and then you're going from 1 ending up to 5, right? So now, and again, remember 5 is not part of the set. If there was this one, equality, we would have included, we would have put the square bracket. So now, since there are no equality here, there are no equality signs here, you're just going to write 5. Of course you should write it, but this time use the parenthesis. If we add equality signs here, it would have been written like this. It would have been written like this. Okay, so you need to know these things. Once you just master these, you can never get any question wrong. All you need to be doing now is just to be applying. And when you're solving these questions, you don't just need to end here. Remember, you need to show the interval. How do you show that? On the number line. Now you have to represent this on the number line. Now let's try to solve some of the questions. I show you how these concepts are being applied. Okay, so now let us solve question 12 from the tutorial sheet. From that tutorial sheet. So question 12, they have asked us in form of set builder notation. So now, as you can see, they want us to find the intervals of A intersection B. Now look at the way they have given, the format in which the set has been given. Look at it. So what you should do, in order for you to not now get confused when you start solving, what you should do, you should convert it to interval notation. So how do you convert to interval notation? If you want, you can first convert it to raster notation, then you take it to interval notation, or you can just easily convert it to directly to interval notation, since it is in set builder notation. So you're going to say A. Let's begin with A. Okay, just before we even begin, let's just convert in advance. So meaning that A in interval form, remember A, they're simply saying that it is starting from 4, negative 4, but this time 4 is part of the set. If you want, you can form the raster notation, or you can just interpret directly from here. Okay, so you can just say here that remember it's part of the set, right? So it's going to be a square bracket. You write -4, you put a comma. Where is it ending to? We're ending at 2. Now this time 2 is not part of the set. Yes, you're going to write it, but what would determine that it is part of the set is the symbol that the sign that you're going to include on this side. And we are going to write, instead of writing this a square bracket, we are going to write a parenthesis, a single parenthesis. Okay, so you have converted this to set builder notation form. So now you are going to write now B. So now B, they are saying that yes, it is a real number, but it is starting from -1, which is included. It's part of the set, so it's going to be a square bracket. It's going to be a square bracket. We are going to write -1. It's separated by a comma. And where are we ending to? We don't know. When you look at the number line, let's say we have negative, let's say we have a negative a, let's say we have negative 1. What comes after negative 1? It is 0, right? A1, right? A2, right? So we are going to the positive side. That's what, remember, there is greater than e. Numbers increase towards this direction, right? Decrease towards this direction. If there was less than e, we would have gone this direction, to the negative part. So now, since we are going to the positive part, and they have not told us where we're ending to, so we are just going to the infinity. So we are going to put the infinity symbol a, and don't forget to include the positive. The moment you write the positive, it means you're saying that we are going towards this part. If you write the negative, you should actually know that, okay, so this guy thought that we are going towards this side, right? So meaning that you're going to get it wrong. You have to write positive in the symbol for infinity, like this. Remember, if it is infinity, we consider it not to be part of the set because we don't know where we're ending to. So you simply put the single parenthesis. Okay, so you need this for you to start solving, so that it can be easy to solve. So they want us now to find the interval for the intersection of A and B. So how do you find that now? So in order for you to find that, you have to use now the number line. You have to plug these two on the number line, then you find where they are intersecting, on where the intersection is, the numbers that are on the intersection. In the lecture, they really want to see you applying that on the number line, so you have to show it. You have to show the work. So you're going to go A. You're going to write A. So they're saying that A is intersecting with B, right? Okay, so now you're going to draw some sort of a number line, some sort of a straight line. So now you need to take note of the numbers that you're going to be plugging. We are plugging on the number line. If you want, you can plug all the numbers, but sometimes you'll be given like big numbers like 20, like 50, maybe, yeah. So you can't write like from 1, 2, 3, counting from 1 to 50. So you just write the numbers that are appearing, but they should be in the order in which they can appear on the number line. Let me show you. So look at the number that we have. We have -4, -1, and we have -2, right? So if we were to arrange these numbers on the number line, how would they appear like? Here we have -4. Which one would come first? It would be -4, right? So you're going to begin with -4. Now which one would come next? That would be -1, right? You're going to say -1. And which one will come next? Okay, but in a case where you have negative and positives, it usually just makes sense to include the 0 so that you can show that here is when now the signs are changing from negative to positive. Then now, which one is coming next? We have only one positive, right? So you just include a single positive number A, just like this. If you want, you can put it here, but you just need to show that this is on the positive side and these are on the negative side. Okay, so now you have to show now each set. You have to show it on the number line that you have just drawn. So you are going to begin with the first set A, right? So now look, we are saying that set A is starting from -4 to -2, from -4 to -2. So now you are going to show it. How do you show it? First of all, you are going to draw a circle like this. Here, where it is starting from and where it is ending to. Then you join them by a straight line. You join them with a straight line, like this. Straight line. You should use a ruler so that they can look very neat. I'm just using a free hand, but you should normalize using a rule. Okay, so you can even say set A. So you have represented set A. So now let's go. Let's now represent set B, starting from -1, right? Where is -1? -1 is here. You can even do like a dash, like, and then you're going to put also a circle here. It shouldn't be shaded. It shouldn't be shaded. I'll talk about the shading part, but first you should just make it empty without shading the circle. Okay, so now starting from neg 1, we say that it is going to the positive infinity, right? So you can just draw a line like this and just put an arrow. If you want, you can even say infinity, but this arrow said it all. It is saying that you're just going to the infinity. You can even say this is b. So by just drawing this, this question usually come with 2.5 marks. You probably maybe might get like 1.5 marks. Yeah, maybe, yeah, but you can get some marks even if you fail to reach the interval part, because we are trying to come up with something like this from the number line after we find where they are intersecting at, where A and B are intersecting at. So by drawing this, what do we mean? So now by drawing this number line, we are saying that this area, this whole area A, is where the members of set A are. Set A members are from A up to A. A, they are just ending from A. They are not going further, okay? But for set B, they are going further starting from A. So set B's members are only starting from A going this direction, right? And set they are not going, when you move towards this direction, we only have set A members. So now you have to see, remember, intersection is where we are having members that are found in both set A and set B. Now when you look at how the number line is, when you look at this side we don't have set B members, right? We are looking for an area where set A, where even set B members are present. Even when you look at this area here, set B members are not, here set B members are present, but set A members are not present. But when you look here between here, all the members are present. The members from set B are ranging from here to here, and from set A are ranging from here to here. So you're going to write where the numbers that are at the starting point and the ending point. Which number do we have? We have neg 1, right? We have neg 1. Oh, and one thing I almost forgot. So before we even reach that part of analyzing, you need to check. You need to check now. So okay, let me now explain how I almost skipped. So now remember when I was saying that you draw like a circle. You draw like a circle. Okay, so this circle is what they call a bubble. This is a bubble. This bubble now is what will tell us whether the number that is at a certain point, for example this point, or this point, is part of the set, or it is what will tell us if that number is accompanied with either a square root, a square bracket and a parenthesis. So if the number is part of the set, or if the number is accompanied with a square bracket, it should be shaded. So now looking at the intervals that we have here, let's go on set A. Set A, only 4 is part of the set, right? So we are going to shade it. We shade what is part of the set. When you look at set B, only 1 is part of the set, right? So you also shade it. The other you leave it and shade it. Okay, so now let us now proceed. So as you can remember, we found that here is where the intersection is. The starting point of the intersection is neg 1, right? So you're going to write neg 1. You're going to write it. Now you're going to see which kind of bubble do we have where neg 1 is. Is it shaded or not shaded? If it is shaded, it means that it is part of the set, right? In that it is accompanied by a square bracket, right? So you're going to put a square bracket A, put a comma, and then you're now going to see where is it ending at. It is ending at 2, right? So we are going to write 2. You're going to write 2. Now you're going to look, what do we have here? What kind of bubble do we have here? Here, the kind of bubble that we have, it a bubble saying that it's not part of the set, and if it is not part of the set, we simply put and a parenthesis. So this is your final answer. This is how you reached your final answer. Okay, so because I remember like in my first test I made a mistake. Instead of making it a square bracket, I wrote a parenthesis. Instead of losing it at 2.5 marks, but I showed everything. I just made a mistake on the final answer, and I got 2 marks instead of 2.5. I just lost 0.5 mark. You see, so here is where the marks are, and you need to show it like the way I've showed it. Okay, these are simply 3 marks. These are very simple. Let's solve question B. Question B. Okay, so now let us look at second question. Question B. So question B, they want us to find the interval of a complement. So now you have to remember, you need to draw. So now when you're dealing with a complement, you have to remember that a complement represents the elements that are not part of the set, right? So now, first of all, you are going to draw the sets that are given. In our case, they are only interested in the complement of set A. So you're going to write, you're going to draw a number line. You're going to draw it. Set A, what do we have in set A? Set A, we only have -2. So you're going to say, let's put it here. -4, a bubble. Let's just put 0 to show the change of sign from negative to positive. And that 2, right? Which one is part of the set? This one, right? Okay, for some reasons, let me just extend it. I want to show you something. Okay, so you put a bubble, you draw a bubble, then you join them. Then you join them like this. So now, after you join them, you can even say this is set A. So this is set A, right? When we try to show set A on the number line, it will look like something like this. So now, when a complement represents the number, the members or the elements that are not part of the set, right? And which area is representing the members that are part of the set? This area, this bit here at the middle, right? So anything that is A is part of the set. Now, what is not part of the set? What is not part of the set is whatever is this side, it is not part of the set, and whatever is this side is not part of the set. So the complement is existing this side and this side, because that is where we can find the members of set A. The members that are not part of set A. So now, remember, I'm saying that. Let me represent the area. So I'm talking about this area, going to the infinity. You need to be careful here. If you are given an intersection, a universal set, whichever number would have come A, it would have been where the end point was, instead of the infinity. Don't worry, maybe in the next video I'll solve a question that is involving a universal set. When you're dealing with a universal set, or here on complement, we handle things differently. Okay, let me just show you here. Let me just solve this one. I'm going to explain. So a complement is on this side, right? This is where the members, the elements that are not part of that A are found, right? So it is here. You draw a bubble here. You draw a bubble. You only do this when you're dealing with a complement. When you're dealing with a complement, you have to you have to show this from you have to show where the members, meaning the elements that are not part of the set, are starting from. In our case, they're starting from A, and where they're going to. So some are starting from -4 going to the negative infinity, and others are starting from 2 going to the positive infinity, like this. Okay, so now what else? So you need now to see. So now how are we going to label these bubbles? How are we going to leave them? So when you're dealing with the complement, you need to see now. Remember that we draw a bubble on top of another bubble, always. Even if you are given like let's say like A intersection B, sometimes it will be like this, a complement, meaning that the complement of this will start from here going here, another one starting from here going here, meaning that here you will be required to put another bubbles only when you're dealing with the infinity, or I mean with the complement only. Okay, so now when you're dealing with the complement, remember we put a bubble on top of another bubble, right? So now what determines how a bubble should be shaded? It is this bubble. If this bubble is shaded, this one shouldn't be shaded. If this one is not shaded, this one should be shaded. So in our case, this is shaded, so we are not shading this one. But A, this is not shaded, so A we are shading. This is what you do. You do the opposite of the bubble that is below. Okay, so let us proceed. So now, so the complement, so we have two sides where complements are existing, this side and this side. So you're going to begin by writing the best side, which is this side. So you're going to say so a complement, remember, so now here we are going to the negative infinity, right? So now where are we starting from? We are starting from A, -4, right? In which bubble do we have here on top? It is not shaded, so you're simply going to say this, -4, comma, where are we ending at? We don't know. We are going to the infinity, so we don't know what's part of the set, right? And we don't have what is part of the set, so we're just going to, we are still going to use the same parenthesis. So we are going to say negative. Make sure you put the negative so that the lecturer knows that you're talking about this side. If you just write the infinity without the sign, it means that you're talking about the positive side. So you're going to say like this. So now, since we have two, we need to combine them. But how? We are going to use the union. Using the union, you're going to unite this side with this side. So now, how are you going to do that? So you are going to write now this part here. So now here, what do we have? We have the A complement. You have the A complement here, starting from 2, and we have a shaded bubble here on top. We have a shaded bubble here on top going to the positive infinity, right? So we're going to say 2. Remember, it is shaded. It's going to be a square bracket, and 2, comma, positive infinity, like this. Always when you're dealing with the infinity, it shouldn't be part of the set. So this is how you solve. This is the final answer. Then you even get the 4 marks here. So now suppose maybe you are given a universal set. Let's say there was a universal set. It was maybe -5. Maybe it was like this. They even say that you also have a universal set. You also have 3. So in a case like this, we wouldn't have put infinity. Sorry. Okay, I've made a mistake here. This infinity symbol should be on this side, and then 4 should be on this side, because we're starting from this side going towards this side. We're starting from negative of infinity going to this side. Okay, so like this, my bad. So now if you're given a universal set, let's say there was 5, meaning that first of all we would have included it on the number line, so it would have been like this. Here, instead of ending at -4, we would have put -5, and here instead of ending at 2, we would have put what's this? Positive 3. So meaning that this time, instead of putting negative infinity, we would have put negative 5. And on this side, instead of putting positive infinity, we would have put 3. That is if we add a universal set. So always, the moment you see a complement, always check, do I have a universal set? This is where most of the students get this question wrong. It plays a very huge part when you're dealing with these questions. So the moment you just see a complement, you should check, is there a universal? If there is no universal, meaning we are going, infinity is going to be involved. If there is a universal set, we won't use infinity anywhere. Okay, so this is it for this video, and in the next video I'll solve more examples.